Oh, so welcome to another class on partial fractions. In this class, we will treat cases with degree of numerator greater than or equal to the denominator. So we are going to start with the example on the board. It says resolve x3 plus x squared plus 4x over x squared plus x minus 2 into partial fraction. Okay, so in this particular example, we discover that the degree of the numerator is greater than the degree of the denominator, and as long as we're going to resolve it to partial fraction, we can't proceed like this. We must start off by ensuring that the degree of the numerator is either equal to or equal to or slightly less than the denominator. So what we're going to do is that we're going to divide the numerator by the denominator. First, solution. So first, divide numerator by denominator. Okay, so it's giving us x squared plus x minus 2. We have x raised to the power 3 plus x squared plus 4x. So anytime we're dividing a polynomial by either its factor or in this case by a quadratic expression, we always use the first term, which is this part here, to divide individually one after the other terms here, and the result we get is to multiply everything here. So we're not using everything to divide. So we start off by saying x to be divided by x2. That will give us x. It's just by saying x3 over x2. From indices, it is x3 minus 2 is x, or there is x times x times x over x times x cancel. So we're going to be left with x. So that's why we have x here. So now that we've gotten x as a result here, this is x to multiply everything here. So x times x squared will give you x raised to the power 3. X times plus x will give us plus x squared. X times minus 2 will give us minus 2x. So when you subtract x to the power 3 minus x to the power 3 will give 0. Here will be minus, so this will cancel to give us 0. Now minus x minus will make it to be plus. So 4x plus 2x will give us 6x. Now we cannot divide x to the power 2 which by 6x because the degree of x here is higher than the degree of x here. So what we're going to do is this becomes our remainder. So we're going to say so x is power 3 plus x raised to the power 2 plus 4x over x to the power 2 plus x minus 2 is equals to x plus 6x, which is the remainder. When trying to divide this denominator by this remainder, we couldn't go further, so this x squared plus x minus 2. So this is what we're going to get. Now this is what we're going to resolve. So this part is already resolved, so we need to resolve this part to partial fraction. So let's say next resolve 6x over x is equal to plus x minus 2 into partial fraction. So let me say let 6x over x squared plus x minus 2 identical to e. Okay, let's see this is a quadratic expression. Let's try to see if it can be factorized. And if it can, then we resolve the partial fraction with the procedure that expressions like this that can be factorized are resolved into partial fractions. But if it cannot be factorized, then we use the other method for quadratic expressions that cannot be factorized. So let's check if this expression can be factorized. We have x squared plus x minus 2. So we multiply this by this, we have minus 2x squared. So we're going to have minus 2x times x will give us, minus 2x times x will give us minus 2x squared. Minus 2x plus x will give us minus x. So this is not what we have here. So that means we're going to change the sign. So if x plus 2x times minus x, we're going to have minus 2x squared, which is what we have here. So plus 2x minus x gives us plus x. This is what we have here. So these are the two factors. So we'll replace plus x here. We're going to have x squared plus 2x minus x minus 2. So x squared plus 2x minus x minus 2. So x gives us x plus 2 minus 1 gives us x plus 2. And we're going to have x minus 1 and x plus 2. So this implies that this expression can be factorized. This expression, so we have these factors. 6x over x squared plus x minus 6e over, before we put it in this form, you can say let it be because it equals, so this is 6x is equals to x minus 1 and x plus 2. Okay, so let's 6x over x minus 1 and x plus 2 identical to e x minus 1 plus b x minus 2. So multiplying through by x minus 1 x minus 2. We're going to have x minus 1 x minus 2 6x x minus 1 x minus 2 equals to x minus 1 x minus 2 e where x minus 1 plus minus 1 b over x minus 2. Okay, so since this one is common to this, to cancel out. One is common factors cancel out. This is common to cancel out. So we have 6x left and e x minus 2 plus b x minus 1. Okay, so eliminate e, put x equals to, we can only eliminate a when this everything here is equal to 0, and we can only do that when x is equal to 2. So we'll put x equals to 2. So if x is equal to 2, we put 2 in place of x, 2 minus 2 is 0, 0 times a is 0. So in that way, x has been eliminated. So put x equals to 2, so this is 6, 2 is equals to b, 2 minus 1. So 12 is equals to b, b is equals to 12. So this plus plus to be x plus 2, x minus 1, so x plus 2 plus 2, x plus 2, x plus 2. So this means, so to eliminate a, put x equals to minus 2, we have minus 2, so this becomes, okay, b is minus 2, it becomes minus 12, and it becomes minus 2, so here becomes minus 3b, okay. So b is equals to minus 12 and minus 3 is equals to 4. So now we're going to eliminate b. And now are we going to eliminate b is when we're able to make it 0, and that's by making x to be plus 1. We need b x equals to 1. So if x is 1, it will give us 6 times 1 is equals to a 1 plus 2. So 6 plus 2, 3, and a is equals to 6 over 3 is equals to 2. Therefore a is 2 and b is equals to 4. Okay, hence thus our expression, which was, so thus we're coming back to this part. Thus x plus 6x over x squared plus x minus 1. We said let me identical to, because x plus e, our e here is 2 over x minus 1 plus our b is 4, that's 4 over x minus x plus 2. There's a factors and minus. In this example, this is what we're going to do. We're going to resolve this. Before we can do this, we need to get values for E, B, and C. And that tells us that this, like the first example, this was, the numerator was divided by its denominator to get a factor here, and then the denominator was factorized, then we got B and C are gotten. So let's proceed. Solution. So first, divide the numerator by the denominator. Okay. So now that we've gotten to this point, we square as the denominator started with 4 times x squared, and when we are dividing the numerator by denominator, we cannot use a constant to divide. Is the 10 in x or x squared that we're going to use to divide. So 4 minus x squared will become 4 minus x squared will be minus x squared plus 4 minus x squared plus 4. We have x squared plus 1. Because as I explained before, this example is x, or this first part that will divide this, and then the answer we're going to get will multiply everything. That's what we're putting here. So minus x squared divided by x squared will give us minus 1. Minus 1 times minus x squared will give us x squared. Minus 1 times plus 4 will give us minus 4. So we're going to subtract. When we subtract, this will cancel. It becomes plus. So 1 plus 4 will give us 5. Will give us 5. Okay. So this tells us that from our division, so x squared, so x squared plus 1 over 4 minus x squared is equals to minus 1 plus 5 over 4 minus 2, 4 minus x squared, 4 minus x squared, minus x squared. Okay. Next, so 5, 4 minus x squared, into fractions. We already have the factors here, but if we are not going to work with factors here, for us to verify that it is a factor, what we have here are factors of 4 minus x squared. We discover that 4 minus x squared is simply difference of two squares, because what you have 4 minus 2 minus x squared, 2 squared minus x squared, which is equals to 2 minus x is power 2. And you know what that implies. So what you have here are factors of this. So we have to say let 5 minus 2x, or 5 minus 4 minus equals to 5 over x 2 minus x minus x 2 plus x. Okay, so we're going to say let 5 2 minus x 2 plus x equals to no, because already what we have here is already taking place of this minus 1, so we always have b and c equals to b over 2 minus x plus exactly what we have here plus c 2 plus x. So we need to find the values of b and c. So multiplying through by 2 minus x and 2 plus x plus x, we're going to have 2 minus x 2 plus x 5 1 equals to plus x. Okay, so this eliminates this. We have 5 equals to b 2 plus x plus c 2 minus x. We can expand and then equate coefficients in x squared, coefficients in x, and constant. But let me just method to eliminate b put x equals to. So b can only be eliminated when x is minus 2, and then it automatically becomes 0, because plus x minus 2 will give us 0. 2 plus x plus times minus 2 gives us minus 2. 2 minus 2 is 0. 0 times b is 0. And b is minus 2. So 5 is equals to c 2 minus 2. 5 is equals to that's plus that's 4 4c, and c is equals to 5 over 4. 2 and eliminates c which x equals to 2. So if x is 2, we put 2 in place of x. 2 minus 2 is 0, 0 times c is 0, so c is eliminated. That gives us b5 plus 2b 2 plus 2. So 5 is equals to 4b. 5 equals to 4b, and b will give us 5 over 4. Therefore, e is equals to minus 1, b is equals to 5 over 4, c is equals to 5 over 4. Then formula, say, hence 5 over 4 times x squared, which is this part alone, is equals to b. This part alone gives us b over, which is 5 over 4 2 minus x plus 5 over 4 2 plus x. Okay, so if we incorporate this part to this part, where x squared plus 1 4 minus x squared equals to minus 1 plus this part that was resolved into partial fractions to get here. So let me say, hence therefore x squared plus 1 over 4 minus x squared equals to 1. So this will give us this. So our a is minus 1 plus, now b is 5 over 4, which is part of the expression 5 over 4 2 minus x plus 5 over 4 2 plus x. So that's it. We're not going to stop here because we have this to evaluate. To calculate a plus b over c. So a plus b over c equals to a minus 1 plus b 5 over 4 over c 5 over 4. So you can write this to be minus 1 plus 5 over 4 divided by 5 over 4. So this is equals to minus 1 over 1 plus 5 over 4. Our LCM is 4. So minus 5 plus minus 4 plus 5 is equals to 1 over 4. Okay, so we have here, which is equals to 1 over 4 divided by 5 over 4. This equals to calculation divided by 5 over 4, so 1 over 4 times 4 over 5, 41. So our answer is 1 over 5. My answer.